What's going on, guys? Chris here. I guess this was probably inevitable if you guys have been watching me with all the modifications to my CNC here, that it was inevitable that I was going to be changing the control board at some point. I did that. I actually got an extra Langmuir board because I actually kind of got used to cut control and didn't want to change it. But I was not going to have, first of all, it wasn't going to the right place. It wasn't, the tool head, when I was running a program, it wasn't ending up in the right place. I don't know how that happened. The new touch probe didn't work for me, but this is my old one. And I checked I did the thing with the ball screws and the 1, 2, 3 blocks and the dial indicator. And I got it exactly to 3 inches when I'm going across the 1, 2, 3 block and dial indicating it right on the next 1, 2, 3 block. It was exactly right on the ball screws, which I did have to compensate for that in the software, but it's still, when it was going to machine the part, it was ending up, maybe I'll put in a clip right here when I'm putting this video together. It was going like 2 inches off. It was starting to machine like 2 inches off of the work. That, and also these have encoders on each stepper, each servo motor, each clearpath. And I'm not getting to take advantage of that because there's no feedback to the other board. This one has that. And also, you know, I'm going to get a different touch probe and a different tool setter. I'm going to potentially maybe use the touch probe and tool setter because I don't know that there's anything wrong with them. But I got a set of new ones just in case, because I don't know. I want to just start fresh and see if that was the problem. And plus, there's some other programs out there that are like the controller programs that have a lot more options with the touch probes to do, like the inside of a board to find the work, and rather than just like the corner probing and stuff like they have on there. When I was doing the lead screw, the electronic lead screw, I watched a video and some guy wanted to see how to crimp these things like easier. He was doing it like on a vise, and it was kind of crazy. So really, you just put these pliers are meant for this, these crimpers, right? You just put this right into here. You see it fits right in, and start it. Let it click one time. Just ratchet it one time so it goes in there. So so it's locked in there. So the fitting is locked in there. Stick your wire right in. Put it right how far it needs to go. Which, if you know where it needs to go, the outer rings that clamp down are to go on the insulation on the sheathing, and then the inner ones are to go onto the conduit, onto the wire, like that. That's not focusing. Can you see that? Let's see. Is it focusing? There you go. That's how you want it to crimp. These are Molex Mini Fit Junior, which is what the clearpaths use. I thought I had another fitting out. I just bought the 3 motors. I didn't buy the wires with it because I have all the crimping tools and the electrical fittings and whatnot. So I just figured I'd make them, and I made them already, but I didn't run high-level feedback or for the encoder wires because I wasn't going to be able to use them with the other board. So now that's changed. So that's why I'm running more wire, which, don't underestimate how much wire you can actually consume doing this. So one of the 2 wire, there's a positive and negative for the feedback, and these are the schematics here for all the wiring. This I ended up going with the Acorn, the Centroid Acorn, that's the name of the board, Centroid Acorn. It's got a 4-axis, which I have the Y-axis. It's actually set up now. It's set up partially. It's set up with motion. I don't have the end stops done yet, or the probe, or any of that stuff. I have the wireless MPG working, which I didn't buy their MPG. I got one on Amazon for 120 bucks. They charge like 300, and it has half the buttons, so you can put a lot more macros on this. But it still works. You can make it work. You have to finagle it, but you can make it work. So I got that working. I got the motion system working. I just need to do the end stops. I'll show you right now the software, and then I'll bring you over here and show you I got to turn it on. I'm not going to communicate with anything because it's not on. And now the enable is not that emergency switch that I had installed on the front of the machine. That was just to cut the enable to all the 3 motors. Now that's actually an emergency switch to everything. So it's actually wired into everything, and the enable does go through that, but it also goes to the board. So like right now they're not enabled yet, but they're going to be through the software. I don't have to, like, that button is not gonna, if I turn that on, it's going to shut everything off. So it's a real emergency stop, which is obviously better than it was. So now once I reset this in here, that should enable them, or this first. Yep, there we go. Now they're blinking green. So now they're just through the firmware, they're enabled. There we go. See, there's the head moving. So I've got it mostly set up. I have to do the end stops. I haven't gotten the spindle. The spindle is the one big thing that I haven't gotten done yet, because the AC servo, I'm waiting to hear back from somebody about how to wire that. If I'm thinking of the way I'm thinking is going to work, I'll figure it out. I just don't know. I don't know how fast and easy it's going to be. It might be a challenging thing, so I'm going to just get everything else done. And I also had to order a 5-volt relay with 3 inputs and outputs for each of the 3 motors, because that's how that gets done. It goes through the main board, but also I have to put a relay, which at this point I don't really have any room left in this electronics bay, electronics enclosure, because I have so much stuff in there. I put a couple more. I got smaller cable raceways because I was running out of room, and I had to figure out a way to make some room somehow. And I got 1 inch wide but 2-inch tall cable raceways. So that made me some more room. And let's see if I can show you, where is it? Yeah, you can see it right there. That's it. I couldn't tell that's it, but it's right there. So they're taller, they're deeper than the other ones. I had a deep one in here already, but it's 2 inches wide. So these ones here, this one up top here, I don't know if you can see all the way over here, but I should probably zoom in a little bit. There we go. So that's what it looks like right now. It's actually nice and neat. I got wires that go to the computer hanging down in front of it. Those are wires that go to the old board. So this is all going to the computer. This is power. So none of that goes in there. Just those few wires that are loose. So those are the old. You see the old board is still here. I still have a couple of connections going to it. These are actually, those can come out. This is just these few wires that still are going to it that I have to label them. And I got heat shrink labeling that I got to print some labels with and label those before I cut them. But yeah, so the Acorn is in there. Here, let me bring you over here. I'll show you how I got everything mounted. I printed mounts for everything. I printed a mount for the Acorn board, the clear plexiglass or polycarbonate cover on it that came with it. So I just mounted that on the 3D printed mount. And that's the relay board. Oh, I have to do the water cooling too. There's 8 outputs. I don't know what you're supposed to use them all for, because the water cooling is really the only thing I think I need that for. I don't think there's anything. And now that I have it and I have all those outputs, those 2 big fans that I put on the top of the enclosure to dry it out, I'll probably start those off of it too. And then there's my splitter that goes to the common ground, and that's grounded right to the case, and then the positive and negative for the 72 volt. And this is the 24 and 5 volt power supply on the sidewall that comes with the Acorn board, which that just has to be mounted permanently. I just have to put another screw in it, which is the great thing about using a metal enclosure, is I can just drill and tap everything and screw it right in. So, like when I did a high temperature 3D printer, that was one of the benefits of having a metal enclosure for it, was that I could drill and tap everything and secure everything, wiring and whatever else. But yeah, so that's just that one driver for the Z-axis. And I do have a 34, a NEMA 34 servo motor that I'm thinking about putting on the Z-axis. It has a built-in brake, but the problem is, especially when you mount this in the higher position, the head. So the head can go in two positions, a higher and a lower position. It gets the most clearance here. I'm going to raise the whole gantry to 2¼ more inches anyways. I think I showed you guys that. So I'm starting to machine the blocks for that. Like I've already started. That big, huge block that I had, this is one of the blocks right here. It's down to like almost, it's about the size I'm going to machine it from. But it's going to be like a long machining process because that cast iron is pretty tough. It's going to have to go kind of slow, and the other one's already in here. But that was a hacked up bandsaw cut. But I broke two bits on these motors. Are so crazy powerful. It was in the wrong spot when because it hasn't been locating right. And it snapped a 1/2 inch bit with the motor. It was on. It was doing 5,000 RPM, and it was just so deep that it plowed right. It wouldn't slow down a bit. It didn't. Those motors have so much torque. You really have to be going the right speed or you at the right depth and all that. You can't. It's not going to stop. Like the motor's not going to stop. You're not going to have anything give you any forgiveness. So if you hit the wrong thing at the wrong speed, at the wrong depth or whatever, it's breaking something. It's breaking the bit, it's breaking whatever. But the fact that nothing else broke, the spindle didn't break, the spindle did stop. The servo went into alarm state, but I mean, that's to be expected, but nothing else. No damage to it, no damage to the motor, no damage to the other motors. They just go into an alarm state, the servos. So and they destroy whatever's in their path. They destroy the bit, and those bits they're carbide bits. I mean they're tough. They're kind of, even though they're really hard steel, they are kind of not brittle. I don't want to say brittle, but they're kind of brittle for what it is. I mean, they're extremely strong steel, extremely tough steel, but they are, like when it's that hard, it's also a little bit of brittleness comes with it. Anyways, these are all different schematics for different things that I thought would be helpful that I printed out, and then the whole manual for the board. I also did try, I had a couple of offline, I was looking at the Masso too, but I got a screen that was like, not a touch screen, but a screen with all different buttons on it, kind of like a big ass MPG that had all the inputs and outputs right on it. And it's you put it on an enclosure or mount it somewhere and everything goes right to the screen. I could have put it in a housing and had most of the wires going into it. And it's an offline controller that you can just put the G code in with the USB. I didn't end up going with that, obviously, but I have so many extra servo motors, the easy servos, and the other spindle motor I don't know that I'm going to use on here, which, by the way, that 2.2 kilowatt one that I tried out, that I got to see if I was even going to like, I decided once I got it that I thought 3.5 or 4 kilowatts was better, so 5 or 6 horsepower, and I ended up getting a 5 horsepower that's in a square mount. It's not that circular one with a bracket, it's just like a square housing. And it's 3.5 kilowatt, 5 horsepower, and 18,000 RPM. So it's a little slower, a little more torque. But I think I'm going to probably end up building another CNC router, like a smaller table at some point. I'm not going to worry about what it's going to be right now, but I'm probably going to build another CNC machine. But I'm not going to buy it like this one I bought and then I ended up building it and then I ended up rebuilding it like I'm doing right now. I'm going to just build it from scratch in the first place, because that's what ends up happening when I buy things that are pre-made. I end up 9 out of 10 times rebuilding them. So I may as well just do it myself in the first place, because this way I know I can do everything the way I want to do it and add the features that I want, which I don't know exactly what those are. I don't even know exactly what it's going to be yet. I know I'm going to do like probably a gantry mill similar to this. with a nice rigid backing plate. I'll probably do something similar to this because I like the design, the C7 ball screws and the linear rails, and they're the big heavy linear rails. This machine is very rigid. It's a well designed, well thought out machine. So I want to do something similar to this, but I'll build it. It's going to be bigger, so I have more working area and definitely more Z-axis height. But for now, I'm going to finish. I'm not going to worry about that any further. My brain's going to start to hurt. I have so much stuff I'm trying to do. But anyways, I want to finish this project before I think about starting any new ones, so I can dedicate all my time to them, and which are all my free time, all my whatever. It's not a lot of time that I have to deal with, but I've managed to make it happen. Anyways, so yeah, I'm gonna finish reading these schematics. I don't want to keep you guys watching a video that I won't be able to really narrate very well, because I'm going to focus on this stuff and try to get this board finished wiring. But I'll pick this back up tomorrow or whenever I can. That relay board is coming in. I have no idea where I'm going to put it. I don't really have any more space to mount anything. Maybe underneath the power supply on that front wall. I'm having to use up the side wall because I don't have anywhere else to put anything. There's not really any room. The Acorn board is a good amount bigger than the other one, and then it has that other board that attaches to it, that's wired to it. So I mean, that didn't help, but I'll put it on the front wall, and then that'll have to be fine. So that's what I'm gonna do. But I'll bring you guys back tomorrow. It's getting late right now. I'm gonna wrap it up soon. I'm just gonna try to wire these limit switches and the touch probe and tool setters, and then I'll change the touch probe and tool setter if I'm gonna change them. But I'm gonna try to just get those last few things done, and then I'll bring you guys back tomorrow. And I have a new tool setter and touch probe coming in the next couple days. I don't know if I'm going to try them and see how they work, and then I'm going to see. I've been looking at the one that this company makes, not Acorn. What is it? I can't think of the name of the company. What a brain fart! It's Centroid. Total brain fart. You see, I'm very exhausted. Anyways, I'm gonna finish wiring up these last few things so I can get out of here, and then I will be back with you guys for you guys in like 10 seconds, but for me in a day or so. And I'll let you know how I make out with the board, get this thing all squared away, where I'm gonna have a lot more control and and I'll actually have the high level feedback and encoders that these already have and are not using. And my Z-axis is a closed loop stepper that I don't have the encoder hooked up, and now I'm going to hook up the encoder to that too. So I've got several more things to wire. I've got all 4 motors need another wire coming back. So I have the connection for the closed loop stepper is just hanging in the back of the housing there. So all I have to do is I have the other end of it, plug that in and waterproof it connected, and then run the wire out. And then the other 3 have to go to each of those motors, which I'm doing right now. So I'm going to run those wires and do this stuff, and then I'll get back with you guys when I get a little more progress made, and we'll see how it's going. But this change in clearpath conversion turned into a whole machine conversion. Power supply, board, that's an upgraded driver and closed loop stepper on the Z-axis, all the other motors, that possibly the spindle. I'm really leaning towards sticking with the servo, but part of me just wants to at least try it. But maybe I'll save it for my CNC when I build one. Anyways, right now I'm just gonna get back to what I was doing, and I'll bring you guys back when I make some progress, so you can see some stuff actually being done. But anyways, hopefully I'm giving you guys some good ideas by recording all this stuff. So I will be back to you guys in a few, or yes, for you guys in a few. For me, I'll see you later. Hey, what's going on, guys? So I don't exactly remember where I left off with this. I finally got the CNC machine squared away with the new board, with the Acorn board. This video started off about the ClearPath motors, which are amazing. They're incredibly powerful. But then I ended up doing a ton of modifications. So there's really not a whole lot of MR1 left on the MR1 at this point. It's, although I changed all the motors, I changed the spindle motor. I did end up keeping. I have a 5 horsepower, 18,000 RPM, 3.5 kilowatt, same difference, spindle motor that I was thinking about using, but I don't think I'm going to be able to replace the torque of the servo. So even with 5 horsepower, I don't know that it's going to be comparable at a low RPM. So anyways, I think I'm going to change the gear reduction from it's right now 2 to 1. I'm going to make it 3 to 1, and I'm going to put a bigger large gear on there, or a smaller gear, or both. I have several combinations ordered, and those take a little while to get here, unlike most of the other stuff. So I have some of them. I'm waiting on the rest, so I can try to figure out a good combination to do a 3 to 1 ratio. But that's going to give me some more speed. I haven't calculated exactly how much. We'll see when I get it. But I did wire the encoder from the spindle into the centroid board. So I was thinking about adding an encoder, which I had another one left over from when I did the lead screw, electronic lead screw. I was thinking about adding that to the spindle, and then I'm like, you know what? I already have an encoder on the spindle. I'll just tap into it, and that's exactly what I did. I just literally checked the wiring diagram, which I got the spindle motor wired properly. I found on the MR1 GitHub. So there's an MR1 GitHub, which I wish I found out sooner, because that really was, it took a lot of time trying to figure out how to get that AC servo working without the manual. It's really almost impossible to do without the manual, but I did get the manual. The spindle is working. Not only is it working, but I have absolute positioning on it, and it's working great. So that's at 70. That's full speed. I'm not sure why it's all the way up right now. So I can put it. This is at 500. Or, I'm sorry, 289 RPM, and then 500, 600, 1,000, 1,400, 17, 21. So I can really control it, you know, pretty precisely. And it has the actual, it's not an estimated RPM, it's the absolute RPM on the screen. So that's great, because that encoder on here, even if I added one that was it was still going at like 200 RPM. I just had to shut it off. Even if I added one on here that was 1,024, you know, the standard encoder. I had a higher resolution one, but I ended up not using it. But if it was a 1,024-bit encoder, pulse per revolution, the resolution of it, it's not even going to be as close to as accurate as this, because this servo motor has a 5,000 pulse per revolution encoder built into it. So not to use it would be foolish, and it would be wasteful, because it's already keeping count of its own rotation. So why would I add another device to do it? Anyways, got that done, and a wireless touch probe I got wired in. I ordered this on Amazon, actually, and it's actually a pretty good touch probe for a wireless touch probe. You weren't going to find these online for much less than $700-800. And this also, I got this on Amazon for $100, and it works perfectly. It works totally fine. Oh, oops. So this works actually. I can go pretty quick with it. So you see, like that's too far. Okay, yeah, I get it. All right, let's reset that. So some of the buttons don't function the way they're supposed to. That's actually, what's that button for? It doesn't do a reset. It doesn't do a reset. That's right. It doesn't. It does start a program and stop a program. If you have something in there that you want to run, it will start and stop that. It'll start and stop the spindle. Which one is it? Oh, it is. So it's actually turning on the spindle right now, but I have it so it's the speed is so far down. You just have to control the speed. I don't have a way to control the speed from this, I don't think. I can program some of the macro buttons, but I haven't done that yet. But anyways, you can move the axes, all the axes. And those ClearPath motors, man, they just throw this thing. It's incredible how fast they move it. And you can move it very slow too. So you have all the way down to this, and then you have like increments. These are manual feed increments that are like 1/1000th of an inch, I believe. So you can move it incredibly slow. And then if you want to move it a little bit faster, that's, you know, so you can go right into a very close space, just like that. And then it's got the Z-axis, obviously works. So that's the only stepper motor. That is a stepper motor, but it's a stepper motor with 72 volts on a high-powered digital drive, and it's a closed-loop stepper. So, and then all of the motors have their alarm signal, the high-level feedback on the ClearPath, and then the closed-loop circuit on the stepper motor on the Z drive. All of that is fed back to the board. What else did I do? The wireless touch probe I was showing you. So this is from Amazon, and it was like $400, but in comparison to, I haven't seen any other wireless touch probe that was a decent touch probe. I mean, it's in an aluminum CNC housing. It's actually well made. It's really, I mean, I don't know how well you can see it there, but so you see, and it's very sensitive. I haven't tested actually how precise it is, but it's extremely sensitive when you see. I mean, even if I touch the housing like kind of hard, it'll trigger it. If I just like, well, I guess it's not gonna right now, but it was. Anyways, besides the point, it works, and it's. I'm gonna find out how well. I'm gonna see just how precise it's gonna be, but I don't know just yet. So recently, I saw a video on some. I mean, not recently. I was watching a ton of videos during this process on other people's modifications on this machine, and during all those videos, I saw somebody had the magnets on the wrenches, and it just was held up right there where you always need to hold that wrench. And I was like, wow, that's a fucking good idea. Excuse my language. That's a good idea. I should probably do that. And I did. I just drilled and tapped holes in them and put magnets with the recess for the countersunk screw, and you never think about it until you start bringing magnets around, but they're a horrible idea in a workshop. They're constantly full of metal chips and giving me splinters, but it's also very convenient to be able to hold that right there. So, I mean, what's the answer? Is it worth it? I don't know. I mean, it's worth it to me. Obviously, I left them on there, so. I think that's too big. Yeah, that's too big. That's the wrong size. I thought this was. Why did I think this was a 3/8? I think it's actually a 1/4 inch. Let me grab the collet for that. It's a, what is this? 5/16. Yeah, it's 5/16. No, it's probably metric. That's probably what it really is. It's metric, I'm sure. And the limit switches with the Acorn board, the original MR1 everything is a pain in the neck, because they have like some trickery done in every wiring. Like the limit switches have some kind of trickery done in the limit switch wiring. I had to run new wires for all the limit switches. The touch probe had trickery in that wire, and this, I did actually run a whole new wire, and you see I put a JST connection on there. It's on the side of the tool head. I am going to do an aviation connector right there, because I'm going to leave that in place for a manual touch, like a hardline connected touch probe for when I need it. If I need it, I don't know how reliable the wireless one is going to be. I'm going to find that out, but I'm still going to keep the other one available in case I need it. But in the meantime, I'm gonna use this until I have a reason not to, or that one works better than the other. But I wanted to have the wires running for it, so I do. The limit switches also had some kind of trickery. When I say trickery, I don't know what they did. I didn't bother taking the time to figure it out. I just pulled it out and ran new wires. So, but if you're going from an MR1, you're going to have to do the same thing, because unless you figure out how they have it wired, which I didn't do, I would tell you if I knew it, but I don't know what they did. It's something with the ground. I don't. They're using some kind of like a conductive contact. Even though they do have power, they have low voltage. I'm not sure. I'm not really sure what they did, and I didn't really want to take the time to figure it out because I had so much other stuff going on. I mean, yeah, I could figure it out. You guys could figure it out for sure. I didn't want to do it, but I got everything working just by running new wire for a few things, which, I mean, it's better wire that I ran anyways. It's better for CNC. And then I did as much cable management as I feel is necessary. I mean, I channeled these on the 2Y motors and then put wire shield over them, the cable chain on the tool head, and you know, obviously less wires would be better, but cleaned it up as best I could. And what else did I do? I think that's pretty close to it. So now the only thing left is the Z-axis gantry being risen, and then, you know, more configuration. But this is pretty well set, unless I decide to change the motor on the tool head, which I doubt I'm going to do. I'm going to look up the torque curve for a 5 horsepower, 3.5 kilowatt, 18,000 RPM spindle motor, and see what the torque is versus this. And if it has any less torque, it's not worth it to me. I mean, the speed is great, but I can get more speed out of this and still have a substantial amount more torque. I need to see what those torque curves actually are, and then make that decision. So I'm not 100% sure which way I'm going to go with that yet. But I'll post videos later on. I just wanted to, you know, come to a conclusion on the video that I had already started with the ClearPath upgrade, and you know, in the beginning with the ClearPath upgrade, I was not sure if I was going to do the control board. And once I started looking into them and looking into other users that had done it, and other users that had other machines that had other software, there's the limitation on speed is not there. You know, so you can only cut 100 inches per minute on cut control. So with the ClearPath motors, I'm sure this thing is capable of a tremendous amount more than that, because, I mean, I've seen that tool head be thrown across this machine so fast the whole machine was shaking. That those motors are incredibly capable. And then I just, after seeing all that and knowing that this was going to be that capable, I said, you know what, it's probably a good idea that I just do it, and I just did it. So I ordered the board, and I ordered it without really a full idea on what I was getting into. It was a lot more configuring and wiring and whatnot than I realized. But in the end, I feel like it was worth it, because now I have no limitations. I can do anything I want to do with this. There's no like certain speed I can go up to, which I know they put that speed in place because that's the capabilities of the machine with all the materials that they were recommending it for, which is stainless, titanium. So I mean, on aluminum, I could use this at a much higher speed. I could be doing 200 inches per minute plus, and you know, potentially with the higher speed spindle, or with this one geared higher, I think I'm probably going to get over 10,000 out of it, or maybe right around 10 with the extra gear ratio. I have to look that up and do the math on it. I'm not sure exactly, but I'm estimating around 10. Maybe I'll get lucky. It'll be a little more than that. I don't know. We'll see. But the other one is 18,000. It's only really aluminum that I would ever be able to use it on. But I don't really use anything that's not metal in this machine. Unless I had a reason to, I guess I would. But anyways, all that stuff, the limit switches were a lot different. The way they were wired, they can be traditional, like 2-wire to each limit switch, but you only have 8 inputs on this board, right? So you can get more. You have to do that Ether 16 board, and then you get 16 inputs and 16 outputs. It's you know, then you also have to spend another, I don't even know how much it is. I didn't even bother looking it up, because I'm only using right now 4 inputs. One for the drive OK signal, no, 5. One for the drive OK signal, spindle OK signal, the alarm for the emergency stop, and then the motors I already said. the probe and the tool setter. So that's 5. I'm using 5 out of the 8. And oh, I'm sorry, and the limit switches. So I must be using 6 because the limit switches go on 1 alone. So they only use 1 instead of 6. You would be using two connections for each axis, which then you have a true separate axis, but it knows each so they're all in a loop. They're wired in series, and it's versus parallel where it would be directly from 1 to 1, 1 to 1. These are run from one to the next, to the next, to the next, like servo motors in a full system would be. So that's I ended up finding that out, and it was too late. I had already run all the wires, and then I just ran it in series behind the panel. So I have, unfortunately, I had to make a bunch of connections. I mean, they're not sloppy, but like I would have done it differently if I had known that in the first place. But anyways, it is what it is. I got it all done, and it's all cleaned up now, and they're run right off of each other. So when it starts doing the x-axis, I'll show you. Let me just set it to go home. So it's only going to do the x-axis right now. Where's the homing thing? Why isn't it homing? All right, well, let me restart it, and then it'll have to home. Okay. I think it was already homed when I shut it down, and then I had to reset it to get it to start again, obviously. Okay, reset cleared, there we go. Emergency stop detected. What's emergency stop? What the hell is this thing doing? Hold on 1 second. I don't know what it's doing. Oh, it's something with the... So sometimes this program, I don't know why. Sometimes... Oh, I have this part open. That's probably why. Oh, right. So the home all ends up being one input, and then which the home all is all your limit switches, and then the e-stop is one, and then the drive OK is another. Spindle OK is optional, obviously, depending on what kind of spindle. And the touch probe and tool setter, depending if they're open or closed, like if it's a normally open switch on the tool setter or the touch probe, then you have to use 2 terminals, and the touch probe or tool setter won't work unless you have that second one. So that's not optional. Home all switch, yes, okay. Press cycle cancel. No, I don't want to cycle cancel. Just home it. Please clear before homing. Home all switch tripped. One of the axes is, that's why it's not homing. I didn't even think about that. My z-axis is all the way up. That's why. Okay. That's why, right? Yeah. Okay. No, it's not why. One of them is still tripped. Which one is tripped? Well, anyways, sorry guys. One of my limit switches is tripped. I don't know which one, or it's a wiring thing. Okay. Oh, this one. Son of a gun. The switch is jammed in. These motors are so damn powerful that unfortunately this has been happening to me with these limit switches. I need to really make these adjustments on the paddle in the back that presses down the limit switch. I really have to adjust that properly, because it's just if it's not exact, it just keeps smashing limit switches. And like they're not, I mean, it's demolishing them. There we go. Oh, this one's not demolished. That's good. Okay, that'll work. I put the bigger switches in here for that even before I put these motors in. I did, but it's just these motors are something else. honestly, if you want a powerful motion system, if you're cutting heavy stuff and the steppers are choking, I can't recommend these motors highly enough. I really can't. I mean, I'm thoroughly impressed with these things. I mean, they are expensive. Don't get me wrong. I mean, $1,000 for the 3 motors is definitely not cheap, but you get what you pay for, just like you do with everything else in life. And frankly, if you want to do it right, just do it right the first time. Do it once and do it right. I should have done that, and now I have a whole bunch of extra motors. But I'm probably going to build a CNC router after this. So I mean, I don't know. I don't want to put a timeline on it because I don't know exactly when, but I'm most likely going to end up doing a router of some sort. Let's see. Yeah, it's pretty good. The probe's pretty good from what I can tell by doing it manually, checking on it. But let's see how this goes now. There we go. That's what it was. It was my jammed up. Oh, you know what? I'm not going to let that go all the way. I'm going to stop it and adjust that so I don't demolish this switch that I am lucky that didn't get demolished already. But anyways, I'm going to wrap this up here. I will bring you guys back for another shot of it actually machining. But let me show you quick before I end this, the electronics bay. I finally got that pretty close to being done. So this is what it looks like now. There's my 72 volt power supply, and the servo drive is back where it was, and that's the Acorn board, and that's the relay board that goes with it above it, and then the one stepper driver with the closed loop stepper, and then that's just more wiring splitter, and then this is a 5-volt relay board that I needed for that's also part of how the home switches are working, and it's also for the that's really more for the alarms on the servos on the ClearPath motors. But anyways, that's how I did that, and then I did the cooling fans. I did go to those turn on when the motors are enabled. So if I reset this, well, once I start moving the axis, there we go. So as soon as it's enabled, when the light's green, then the fan turns on. I put Noctua fans on there. The other ones were kind of loud, but more than that, I ended up changing the voltage for the alarm, or for the, I'm sorry, I had power going there for the signal. The signal going to it, I had 24 volts for the enable signal. I had a 24 volt power supply feeding the enable, and I had an emergency switch which I replaced with that on the front leg right there. It was just mounted into the leg, and I ended up getting a couple new emergency switches. Anyways, I had the 24 volt enable going to it with the emergency switch as a way to enable and disable it, and I had 24 volt fans, and then I needed to get 5 volt fans because I had a 5 volt enable wire. When I got to the point where I knew what the voltage was going to be from the Acorn board for the enable, and the way they have the ClearPath set up with the ClearPaths is there's the power supply that comes with it has it's a dual voltage, so it has a 24 volt and a 5 volt output on the same power supply, which I had a 24 volt and a 5 volt power supply, and I wasn't going to use that, and then I ended up using it because the common that's shared on it, the ground that's shared on it, it ended up being useful, so I did end up using it, and I mean, it's fine. There's nothing wrong with it. It's just, it was neater to use the DIN rail power supplies that I had. It was, more organized to keep the cabinet cleaner. But anyways, it worked out just fine. I mounted it on the wall. So once I found out I had a 5 volt power supply going for the enable and disable, I ordered the 5 volt fans, and I ordered the Noctuas because it was already, it was pretty loud. I knew it was it's not loud. When the machine's on, it's loud anyway. And frankly, the electronics cabinet is louder than the fans were, so it was kind of pointless. But I ordered them because I was already ordering 5-volt fans. I may as well get good ones. So that's that. And yeah, I mean, I'm ready to start making some stuff. So I have a couple designs I'm ready to start machining, and I will get you guys some video of it machining as soon as I start making one, probably later today or tomorrow. But I figured I would just wrap this up so I could put this video out so you guys could see. I know when I put out MR1 videos in the past, a lot of people watched them and had questions and whatnot. So I figured this was important to get out, so you guys could see, and hopefully, if anybody's looking to do some of this stuff on your own machine, you could see what experiences I've had, and it was frustrating and fun at the same time. It was, it's something I look forward to doing and I have a good time doing, but can be very frustrating also. So I hope that helped you guys. I hope that you guys enjoyed, and I will definitely get you some more videos of it working. And if I do end up building my CNC router that I'm imagining in my head, after watching all these videos, I'm like, you know what, I could build something like that's big, like these big ones, and that's as powerful as the MR1 and as strong as the MR1, and even maybe a little stronger. I could go even a little further and make all the parts myself. And not all the parts. Like, I'd probably buy aluminum extrusions just because they're so much easier with mounting holes and whatnot, and not having to make holes in everything everywhere. But other than that, I think I would make my own everything else, the gantry and that type of style. But I would make the Z-axis tall. Anyways, let me not get carried away thinking about it, because then I'll end up doing it. And I just want to finish my gantry risers right now and get this gantry up higher, and then maybe I won't need to do it. Because who needs like a 6-foot CNC machine anyway, right? This guy. No, I don't really need it to be that big. Anyways, I hope you guys enjoyed, and I hope that you learned something. I hope that I was able to help you out, and I will be back with you on the next one. All right? Take it easy, guys. Oh, that's not going to help me move that video. Take it easy, guys. Have a good night. Later. What's going on, guys? Chris here. It's been a long night. I actually didn't think I was going to be. I'm going to add this to the video with the ClearPath motors. I did the first video with all the other motors that I tried before I ended up going with the ClearPath motors. But I didn't think that it was going to be. I was still not going to have aired that, because I've been spending so much time doing this that I haven't really focused on editing the video and putting them all together. There's a lot of clips, as you'll probably notice when you see it, but it's consumed a lot of time. I mean, if you see all the documentation I have all over the place, like, I've been reading all this stuff and really here, this is why. So it's paid off for sure. And look at the accuracy I just got with the probe on this. Literally zero error. Zero, not 001, 0001, 0 in 5 decimals after the 0. It's all zeros. So that's why I have spent so much time focused on this, because I got it perfect. And these motors are so powerful, these ClearPath motors. I've smashed every kind of limit switch you could imagine. I've smashed so many limit switches, it's unreal. And I'll show you the evolution of limit switches that I've been through. So it started, the MR1 originally comes with pretty small standard, not the tiniest, but pretty damn small limit switches. So these are the first 3 that I went through. So these are, the original ones don't have a roller, but I just put the ones with the roller. So it started with something small like this. Then I got waterproof ones that were a little bit bigger, like this. Smashed many of these. And then I got bigger ones like this that are also waterproof. Much more robust. Smashed a ton of these. Smashed probably more of these than any of the others. Then I went to these. Next. Smashed them. Smashed all of these. The only, not even, actually, it's the next one up that I still have one of. I smashed a ton of both of these. And the next one up, I do have one over here. This is the one that I still do have one on the Z-axis, is one of these. They're plunger style, but just really beefy switches. So now this is the only axis I still have one of these is on the Z-axis. I ended up going with really big ones that have like a huge metal housing. They're a smaller switch inside, but it's still a big switch compared to the original ones. It's like 4 sizes up, but the housing is massive and it's a big metal housing. So the ones that I'm using now are these monsters. You can see that on the x-axis there. So it's a big limit switch, and the plunger style, they work great. I mean, they're really accurate. They're just as accurate as any other limit switch, but they're really beefy. I mean, the ones with the rollers, I feel like they do get a lot more accuracy, and I'm not just assuming that. When I originally changed them on this from the original ones that came with Langmuir from Langmuir, I zeroed it, and then I switched the limit switches without changing anything else, and zeroed it again, and it was different. Like, I did a zeroed work coordinate at the 0, and then I zeroed it again, and I was off. So it definitely it's more precise. It was more precise on like, I didn't move the limit switches. They're the same size switch in the same place. It's more precise. They're more precise. And the ones from Langmuir had like a little bump out in the metal wasn't just like a flat straight piece of metal, the clip that sets it. It had like a bump out, a rounded bump out, and the wheel replaced that bump out. So there was like no variation in the size. And I checked it. There was really no variation in the size, a very insignificant amount. But there was a significant amount of difference in the homing location. So it definitely made a difference. But anyways, the larger ones just are because of, I mean, if it gets smashed into by accident or something causes continuity. Speaking of continuity, I had a big issue with the metal housings on these and not getting interruption in the signal, because it was making contact with the housing was making contact with the motor frame, and everything's metal, so it's contacting ground. And for a low volt signal, it's not hard to ground it when it's in a metal enclosure, metal housing, metal gantry, metal everything. So anyways, that was a big pain in the butt. I spent a lot of time on that. But so I got a tool setter finally. I got this little kind of cheap one. I have another one on the way. I'm getting I ordered a renishaw. Hold on, I forget the model number. It's a renishaw T27, I think. Let's see. I ordered it on eBay. I found a used one on eBay for actually a pretty good price, like $300, $350 or something. I'll show you. Let's see, right here. I have $344. Yeah, but so I think I paid like $360 out the door. Let's see. That's it comes with the interface, and then it's a TS27R. So you get the renishaw interface, and then the tool setter, and it's a multi-direction, so it can detect the size of the diameter of the tool. It can detect if the tool broke, if it's chipped or anything, and obviously the height. So I'm excited to see how well that works. This one is frustrating. I mean, it works. It measures the length of the tool, but honestly, when I was setting it up, I wired it exactly the way their diagram shows, which they sent me again when I asked them what was going on with it. And I don't know why they sent that to me. It's right on their website. Maybe they thought I didn't even look or something. I did, and I already had that and already read it. And every bit of documentation they had, which was really nothing more than that. But anyways, it literally went from a normally closed switch to a normally open switch without changing any wiring. and I don't know how that's possible, but it did it. It literally was showing up as a closed circuit on the when you hit Alt I, and it comes up with all the inputs and whether they're open and closed. It was a closed circuit, and then it was an open circuit. It was really, I've never seen that happen before with any kind of switch. Either if it's an open circuit, it's broken, but it was closing when it was touched. It was, I don't even know how to, and I asked them and they haven't responded. So, I mean, that goes to show you, they probably don't even know. I mean, I would think they would. I mean, they have a business in this business, so I don't know why they wouldn't know. But, I mean, they're not giving me any information other than the diagram on their website. So, I mean, what am I supposed to think? Anyways, I'm looking forward to getting the renishaw. This was 120 bucks. It's not the end of the world. You know, it was like a little more than an Amazon, you know, little shit tool setter. But it is what it is. I mean, it's working for now in between waiting for the other one, and while I was looking for it until I found it. But everything went incredibly well with the conversion. It was a lot of work and not everything went perfectly. Like there was a lot of hiccups. There was a lot of frustrating stuff that happened and whatnot. Oh, and for the grounded limit switches, I have a rubber buffer, like a piece of sheet rubber between the switch and the frame, and then I have another two pieces underneath the washer between the screw. You know, like the screw hits a washer and then the washer hits the rubber, and in between the screw and the housing is all liquid electrical tape. So there's nothing making contact. There's no metal on metal contact. Which was a pain in the neck to get that to happen without no metal to metal contact in a metal housing to a metal frame, but I did it. So if you guys end up having to get bigger switches like this because of these ClearPath motors having so much power, then that's a way to do it. Like little sheet 3M rubber, cut it underneath where it's going to be the only thing making contact with the frame, and then a couple little pieces on top where the screws go through, and so that's the only thing making contact on top, and then liquid electrical tape, like the canned liquid electrical tape. That's what it's called. It's like a thick rubber. It's liquid, but it's very thick, and when it dries very thick. It's almost like tire. If you've ever seen like tire, the materials you use for tires for multiple things, like for patching them when you do like the real patches when there's a hole and you have to grind it down and you put the fill rubber and the patches and melt them together. It's called vulcanizing. It's called vulcanizing. Anyways, I don't know if you've ever done that, but a lot of the materials for tire repair are similar. I can't think of anything else. I mean, it's not like roofing material. Roofing material is also, it's much thicker and it's just different. Also, I got new microphones, and I'm kind of happy about it, but I'm kind of conflicted because I bought this really expensive. I got a Sennheiser body mic, and it's a really expensive microphone. It's like a $600, almost $700 microphone, just the one body mic and the receiver. And I got the DJI ones for 160 bucks for the receiver and two microphones. And I don't know, I recorded a little clip and played it back, and it sounded pretty close to the same. You guys let me know if you think it doesn't sound good. This is the only clip on this video so far that has these microphones. They just came in. But I got them because when I'm using the GoPro, the Sennheiser is kind of a pain in the neck it's not as small of a receiver, nowhere near as small. It's not big, but it's big compared to on the GoPro. It's big. Anyways, the point of the GoPro is for it to be small and mobile, so I wanted to get something smaller that would work with it. And the little USB-C thing that I had that goes in the phone didn't work for it, so I got this, and it's actually the quality's really good. No surprise from DJI, but I wanted to try it out and see how it sounds. So hopefully it sounds good, and the GoPro clips will be better sound from now on. But anyways, the limit switches caused me some headaches, but that's how to resolve it. If you have that problem, if you have to go with bigger limit switches or want to, whatever. I wanted to, I probably should have sooner, but I just kept thinking like the next one was going to be enough. And then that cost me a bunch of money in broken limit switches. So, you know, not a crazy amount. They're pretty cheap, but regardless, more than it needed to be. You know, it's just a big waste. I should have gotten something really, really hardy in the first place. But anyways, maybe you'll learn from my mistakes in multiple instances. I do watch a lot of videos on YouTube, and if I've learned from other people's mistakes, but more often than not, I'm doing things that are not on YouTube. A lot of the stuff that I do, I don't see on YouTube. Like there's some MR1 videos, and there's some people doing some modifications, like new drives for the stepper motors, new drive, you know, stepper drivers. There's one guy that actually did a big modification. He had a tool changer in and a new spindle. I mean, I shouldn't say a big modification. I don't think he changed much else other than that. But he did change the spindle motor, which I think it was a 2.2 kilowatt. I have a 3.5 kilowatt, a 5 horsepower spindle motor that's at 18,000 RPM. I haven't changed it because I think I'm going to have so much more torque from this. But what I did do is I ordered the gear reduction to be a 3-to-1 instead of a 2-to-1, which I did find out it's going to be around 10,000 RPM. So I'll get another couple thousand RPM out of this one, and I think it's not going to be a big difference in torque. I actually have a bunch of high torque drive 5 HTD 5 pulleys and belts, but I didn't have the right combination. I mean, I have like a whole bunch just from different projects. These are some of them, some of the smaller ones, bigger ones, but this is way too big to fit in the housing the way it is now on the MR1. This one fit, and one of the small pulleys, and I could get a 3-to-1, but it was so tight with this one, I couldn't get the, I mean, it did fit, and the belt fit and everything, and it was on there, but it didn't fit where I could get to. There's 2 screws when you put there's like where the servo motor mounts on the top, and then the belt goes underneath and goes to the spindle. That little spot where the belt is in the middle, you can't get the Allen key around the side to unbolt the top that you have to get it off. So I ordered another set that's a 3-to-1. I think I did like 12 to 36 tooth and then I think the 305 belt will fit. It should be able to fit on the same belt with those, because it's going to change both sizes, but it might actually need a little bit smaller belt with those, because what they have now I think it's a 50. It's not exactly 2-to-1, but it's very close. It's probably as close as you could get with those sizes anyway. You could definitely get a 2-to-1. You could do a 2040. I'm not sure why that's not what they did, but it's very close to 2-to-1. So honestly I didn't even take note of how far off it was. Like only a couple of teeth off. I think it might have been 2 or 3 teeth off. But whatever it wasn't significant for me to really, and I know I'm going to change them anyways. I will take note of it when I take them back off, and I'll show you guys the old pulleys that I take out. But anyways, I'll get 10,000 RPMs that way, and I'm good with that. This motor's got so much torque, and I've been able to cut through some incredibly hard materials with it, like stuff that the Precision Matthews won't even go through. And I mean, not that it won't go through, but it won't go through nearly as easily. This thing goes through material even dramatically better than that. Even automated, but controlling it manually, but fast. I mean, it'll go through way faster than the Precision Matthews, and it's just less of an effort with this machine. It's just much more. Obviously, at this point with the cement and everything assembled, it's probably like 1,500 pounds. So obviously that's a big difference. That PM30 is like just under 6. It's probably over 6 now with all the stuff I added to it. But anyways, it's almost triple the weight. So the cement really does a lot for the rigidity. And the gantry is obviously very rigid. The only thing I do want to do other than the pieces that I have to, now that I'm almost done with this. I keep saying that and thinking that, but I keep doing more. I'm actually going to make myself be almost done, because now that I got this so precise, I don't really want to change a whole lot. I frankly, putting on the Z-axis gantry risers is going to be frustrating, because now I got it so accurate, and I'm going to have to compromise that and do it again. It's very frustrating, but I don't know how soon I'm going to finish them. So I'm going to put this video out without that done, because that might not happen for a little while. You know, I have a lot of other stuff going on, and I've put a lot of time into this recently, you know, trying different things, multiple motors. You guys saw the other video probably, and I did a lot of trial and error with different motors. This is the second set of servo motors, and then, you know, the steppers before that, different drivers, just way more stuff than I needed to if I had just gone right to the ClearPath, but I wouldn't have known that that's what I wanted to do if I hadn't tried all the other stuff in the meantime. So anyways, all the other stuff, the other servo motors that I really have the most of, I still have a few steppers. I have enough steppers to do everything with steppers if I needed to. I have 3 more NEMA 23, and one more big one for the X if I needed to put it back on, and two more shorter but high torque and high voltage motors for the Y-axis. And then there's already a closed loop stepper on the Z. So I could make it back to steppers if I needed to, but I'm not going to do that. I just didn't know if I was going to ever have to before I got this far with the servos, but now I'm not ever planning on putting those back in. But the other servos that I had before this, I'm going to use those. I think I'm going to make the Precision Matthews CNC capable at some point. I didn't think I was going to do that when I got it, but I've been thinking about it, and I mean, I'm still going to be able to use it as a manual mill, which I can this one is actually more like a manual mill now than it was before, because using a keypad is not like a manual mill. You couldn't really hook a regular MPG up to it before. It just cut control doesn't want to comply with anything else. So I'm glad that at least I can have it feel like a manual mill, but it still doesn't. It's still in this big enclosure. It's not really, you're not as up close, and you don't get the feel of it, like the physical actual feel in your hands with an MPG. It's closer, but it's not that close. Anyways, and the cooling system worked out great. The cable management is much better than it was, and you know, that's about it. I mean, it's not it. I mean, I did a lot. I did change a lot, but it's just about done now. I mean, other than the tool setter, and this touch probe is actually really good. I'm really glad that I got this. I got this on Amazon, believe it or not. But it was like $400. I know it's like another company selling it on Amazon, so it's not really from Amazon, but I got it through Amazon, which is surprising to get a good one, because it's actually really accurate. And those are renishaw style. I got a renishaw stylus. I got a few of them, different lengths and diameters, but I actually don't really like the big diameter. And it does know. I got the program. There's a probing program for Centroid that somebody made. Swissy is the name that he goes by. He's in the forum, and it's called Chips, like you're making chips, CHIPS, or eating chips, or whatever you want to think about. And it's actually really good. It's got a lot of that's the program I just used, and it integrates very well with Centroid and CNC 12. So, you know, it's just like using it with something that belongs with it. They developed it that way. Anyways, these are the probes I got. This is another renishaw. This is just thick, and it has a large stylus ball on the end. And then there's a couple other, like there's a really shorter one. This is also another renishaw one, which I was thinking about getting one of their touch probes because they have such a good reputation. These are just like a box full of different probes. They didn't come together, but I just ordered a bunch of different sizes and lengths. So that's the different ones I ended up with. But that one on there I like the best now, because the ceramic material for the shaft is a lot more sensitive from what I can see, what I can tell. And that has a smaller diameter stylus, which I don't know if it's any more precise. It does know by the size of the inner diameter of this bore, which is it's like a calibration thing, but I machined it myself, but I know the diameter. I mean, I measured it. So anyways, it knows the diameter of the stylus ball just by probing it. You tell it the diameter of the calibration circle, and it calculates the diameter of the ball on the stylus, which is pretty cool. It did that before it did this calibration right here. It did one probing cycle like that, and then to tell the stylus ball size, and then another one to tell the diameter of the bore. And then it shows you the amount of error, which I was pleasantly surprised by after all this hard work I put in here. It's been just a lot of like the wiring and the configuration and the software. The hardware stuff is relatively easy. There's only a couple of things that gave me a hard time, like figuring out what was going on with those limit switches. And then also I did already do it, and then I kind of undid it. That's the software right there that just popped up. That's the chip software. You can calibrate this. So because I have the two motors on y-axis, and if you have an MR1, so do you. You can synchronize it so that it levels, or levels, evens out, whatever, the y-axis motors that are paired. So, and it's actually set up specifically for that, because a lot of gantry routers, gantry machines have two y-axes, and to square that up, square it is, yes. And I also, so not to change the subject, but I also got new couplings for the motors, because these motors, the ones that I bored out to the right size, they have so much torque, they were slipping inside of it. I could have probably put a set screw, just drilled and tapped a set screw and put that in, but I ordered new ones, couplings that are, I actually ordered them small, and I did drill them out and bore them out, but I also redid the holes for the screws that tighten them, and I basically remachined it. I just got them small so that I could do it myself, because the wider ones, I had some wider aluminum ones that were really cheap on Amazon that I ordered, and honestly I probably should have just made those. Those were pointless to buy. I could have made them, but the steel ones are a little bit more challenging. I could still make, but for 25 bucks for 4 of them, I didn't even need all 4. I got an extra one. I didn't change the coupling. Oh no, I did machine out the coupling on the Z-axis, but that one's holding up good. The aluminum ones weren't worth buying, but these ones I feel like they were, and I just got them small so I could machine out how I needed to for the size of that shaft. And as everything else is on this machine, it's a standard size, even though it's a metric thread pitch. It's the thread pitch is I want to say it was what the hell did Jake say? It was I want to say a 4mm, 5mm thread pitch. Anyways, if you actually measure and do the rotation, and I did it across 15 inches, and it's consistent, it's 5 turns per inch. So these are C7 ball screws that are 5 turns per inch thread, which is, whatever that breaks down to, but that's the calculation that the software wants, and most softwares want, is how many. If you're doing inches, they want to know how many turns per inch, how many 360-degree rotations per inch. So if you just do 1, 2, count however many, but do a 360-degree rotation however many times you need, and if it doesn't line up to exactly an inch, then you gotta, I don't know, mine did, so you have to figure that out if it doesn't, but it should add up to an inch after a certain amount of rotations. I mean, these are metric ball screws, and they do. So it must be, 25 millimeters and an inch are pretty damn close together. It's like, I think like 4/10 of an inch or something apart. I think it's like 25.4 or point something. I don't remember exactly, but it's very close. So anyways, the ball screws are good quality, and the ball nuts are good. A lot of the stuff is good quality, so there's no point in changing it. You see, I didn't change the motor, and I have a really good spindle motor. I mean, as far as I haven't really used it yet, so I don't know, but I know it was expensive, and I know it's supposed to be a good motor. So hopefully it actually, I mean, I shouldn't speak too soon, but hopefully it actually is. But anyways, the software's, I'm a little all over the place right now because I'm like delusional from being up all night working on this thing right now. I'm still up from like the whole night almost now. I didn't plan on doing that, but I was helping a friend that is getting a divorce and has a kid and a baby that they just had like not that long ago, and you know, he had to put a crib together and everything, and he's one of my very close friends, so nothing I wouldn't do for him. So I was out there putting together a baby crib and furniture and whatnot for him. So anyways, that's why I'm a little all over the place, because I'm scattered anyways, and I'm OCD and a little nuts anyway, but mainly because I've been up so long. But yeah, so I'm very happy with the software. I'm happy with the outcome. I'm happy, especially because I can go over 100 inches per minute. Like you can't even jog over 100 inches per minute with cut control, which is kind of shitty, because I mean, I can't say anything against it. I shouldn't say anything against it, because they made it the speed that they know it can function properly, which is the right thing to do. So they didn't do anything wrong. I'm not shitting on them or anything in any way, because they really, I mean, they know it can cut well up to 100 inches per minute with the way that they made it, and they set it to do that, which is the right way to do it. I just made it capable of more and wanted to be able to take advantage of that. So I'm glad that I'm able to. And hopefully some of my experience, good, bad, and indifferent, will help you guys, and you know, I can spread it around, share the experience that I gained, because it didn't come for free, and it didn't even come cheap. It came rather expensive, frankly. So that's it. I'm gonna wrap it up so I can go and get some rest before I go help my brother-in-law now. I got another day of favor work. But anyways, I will see you guys soon. I hope you guys enjoy the video. I'm going to put it out soon. I don't know if I'm going to narrate any of it or anything, but I was talking during the video, explaining what I was doing, but also when I'm focused on stuff, I'm not really that focused on describing it like I probably should be when I'm recording it, but I'll narrate some of it if I need to, or I'll at least write text comments on the screen. But hopefully you guys will get what you need out of it when you're modifying your MR1 or whatever CNC machine you're watching this because of, whatever, or if the motors or whatever. Speaking of the motors, not to bring anything else up because I want to wrap this up, but I ordered a motor torque tester, so I will do some torque testing, and I'll show you guys. The ClearPath, I'm not going to take any of the motors out, so I may actually get another one for the lead screw, but I'm going to use the servo motors I already have for the Precision Matthews when I do that. Another thing about the machining stuff, I actually got a collet chuck. I got a 5C collet chuck, and I don't really like the 5C collets. They're pretty frustrating because they really only do clamp down in the front. And if you're not holding something short, don't even hold it, because in the back it's moving. So it's just, anyways, I ended up making an ER32 collet that had an MT4 taper. I ended up making the drawbar to go in the back of my lathe, you know, on the other side of the spindle, and pull the ER32 collet in the front. It's an ER32 that has the full closing collets, because those are so much better. And now I have this freaking $350 5C collet chuck and another 100 on collets that I don't even want to use. They're very frustrating. If anybody wants a 5C collet chuck with a lathe chuck plate that fits my lathe, or you could take it without the plate. That's how I bought it, without the plate, for $350 or $79. I think it was almost $400, and then another 100 on the chucks on the collets. So it's like $500. Anyways, anybody's interested, you can have it, because the ER32s are so much better. They don't go up quite as big. I have up to like 1 1/8, I think, in 5C collets, but in the ER32 I have up to 15/16, and everything fit. Everything, it can be tightened down, and it could even be a little small for it or a little big for it, and it'll still work. ER32s are so much better. They're just like the ER20s on this, only a little bigger. I tried to convert this to an ER32, but the spindle, the way they have it set up, is not meant to be changed unless you really want to have some custom stuff made. So I didn't go through with making it an ER32. I wish I had, but I don't feel like sourcing all this unique custom stuff and having it made. I don't want to deal with all that. So I'll just stay up to half an inch and under, or I'll just machine down the shaft of an ER32 and make it a 1/2 inch, like I did with the 3-inch surfacing bit, and I'll adapt it that way, because I'll have 2 1/4 more inches of height soon. So yeah, I'll figure that out when the time comes. But anyways, enough talking. I'm gonna wrap this up, and I'll probably have to describe some of the video during it, and I'll speak to you guys then. But for right now, I'm gonna, I do want to mention one other thing. This thread tapping arm right here, I think I've mentioned it before. I just threaded the M16 by 2.0 threads for the drawbar, and that thing is a freaking monster. That thing has so much torque. That's a NEMA 23 servo, AC servo motor, and it's a pretty long one. It's that whole, it's square inside. It's like a NEMA 23. It's the same as the other. The ClearPath are round, but this is square, just like the other typical stepper, but it's an AC servo, and it's got so much torque. This thing has an astronomical amount of torque. It's unreal. It just plowed through like it's pretty. I forget exactly what steel it is, but it's a carbon steel. It's a pretty serious metal, and it snapped this shaft up in here in the collet. It snapped the squared off. I had to machine a new square on it and machine it down more on the lathe, so I had more room to get it to latch in. It just tore it off. It's got so much torque, it's unreal. Making those threads, it tore it right off. And the threads came out beautiful. I'm actually, before I wrap this up, let me just show you, because they came out so good on that. It looks almost like I turned them on the lathe and did 25,000 passes. They really came out pristine. That's all from that to threading arm, and because I had the die for it. Where is it? Oh, it's on it. I have up to 26 millimeter. 20. This is my larger die kit. They get pretty big, but this is actually one of the smaller ones in it. That's all large sizes. It starts at an M6, I think, and it goes to 20. What the hell is that? M24. So it goes up to, and in the standard set goes up to 1 inch. And those actually weren't too bad for what it is. I mean, for those sizes, those kits were $100 each. 100 for the standard, 100 for the metric. So yeah, and I spent $200 and got them both. And because there's a lot of times when I'm working on cars mainly that I need to thread bigger bolts, and I was tired of not having the right size and having to make them on the lathe, which, is not the end of the world. I mean, I did that electronic lead screw to be able to do it on the lathe, and I'm happy that I can, and I'm happy that I did that. But also, when I'm in a rush because I'm working on another project and I'm just making a part for it, and it's not really like a project, it's like a repair that's a necessity for a vehicle or whatever, I don't want to spend a lot of time like making threads because I'm not enjoying it. I'm just doing it because I need it. So at that point, I just want the most efficient way to do it that's going to do it right and do it well. And that thing does it really well. And those dies actually work really well. I didn't even break one tooth making these threads in this steel. So yeah, it definitely works really well. It's a very good $800 spent. You know, like that you can't spend $800 much better than that in a machine shop. So anyways, that's it. I'm done. I will see you guys when I narrate the video, if I even have to. I'm going to check when I go through it, but if I do, I'll talk to you then. If not, I hope you enjoy the video, and I hope that it gives you guys some kind of insight on any of the stuff that you may be watching it for. And if you do have any questions, just mark it in the comments, and I always respond. If any of you guys have ever left comments, I'm sure you can attest to that, because I really do always respond to everybody. So if you have any questions or anything I didn't mention or didn't touch on that you need to know, please feel free to ask. Okay? Have a great night, guys. I'll talk to you later.